All right, everybody, how we doing? Hope we're all doing well. Welcome to the very first video lecture that I'll be doing for this new unit here. Again, we're working in Chapter 9 here. Chapter 9 is our fourth unit that we're doing this school year. Practice problems that we're going to be kind of doing throughout this whole unit here, Chapter 9, P22 to P28, and then another smaller section, P37 to P38, okay? And again, those practice problems are not going to be ones you guys are doing at home anymore, right? Those are going to be kind of things you do here in class, right? So this video you're watching right now is something you're going to be doing at home now, right? This is the whole idea of the flip classroom. So again, all right, let's just get right into it here. So Chapter 9 is titled Electrons in the Atom and Periodic Trends. So just to kind of give you guys an idea of a couple of things just based on the title of this chapter here. Electrons in the atom. All right, so to start that out, last chapter, right, Chapter 4, we talked a ton about subatomic particles, right? We talked about protons, we talked about neutrons, and we talked a little bit about electrons, okay? But that little bit of electrons was only talked about last chapter because this chapter, Chapter 9, talks a ton about electrons. And electrons are incredibly important throughout all of chemistry, and that's why we spend a lot more time talking about them in one chapter here as opposed to talking about them anymore in the previous chapter. So we'll be touching on electrons a lot this chapter and in further chapters out. And then that second part there, which is periodic trends, that'll be kind of like the tail end of this chapter. We talk about some periodic trends. Right? We learned about the periodic table towards the end of Chapter 4 last chapter. So now we're going to also spend some time talking about some trends that you can see whenever you look at the periodic table. Because the periodic table is not just a list of elements, okay? It's got a ton more of information on there than you would actually normally think. And that's where this periodic trend stuff comes into play. Okay, so let's jump right into it. Electrons. Okay, so electrons, guys, they determine most of the behavior of an atom. All right, so whenever we think about atoms, a lot of the behavior, a lot of the physical, and a lot of chemical properties of an atom, of an element, are all based on the number of electrons that that particular element and that atom of an element have. And so it's actually more than just the number of electrons, okay? And we'll talk about something called electron configuration in the next couple of days here, but that is really the basis of these behaviors based on electrons. So electrons are arranged into energy levels where the first energy level is the lowest energy and is located closest to the nucleus. Okay, so there's a couple of words and phrases in this bullet point here that have some familiarity to you guys. Firstly, we're going to see the words first energy level, right? First energy level. Well, what does that mean? Last chapter, we talked about these things called Bohr models, right? It was one of the different types of models of the atom, right? The Bohr model. And I'll show you a picture of it in just a second here after this slide. But the Bohr model was one of the more important of the different models of the atom, right? And the Bohr model is one we're going to focus up a lot on this chapter as well as some subsequent chapters as well. So Bohr models are really important. And that's where that energy level stuff comes into play. Well, when I say the first energy level, that one is going to be closest to the nucleus. And when it's closest to the nucleus, it also has the lowest energy. So whenever there is an electron on the first energy level, closest to the nucleus, it has the lowest amount of energy. The farther you go away from that nucleus, the higher your energy becomes. And that's kind of where this comes into play here, where it says electrons in higher energy levels further from the nucleus have more energy. And guys, just so you are all paying attention, the bolded and underlined words are things I also kind of want you to put some emphasis on too. So when you see lowest energy in bold and underlined, please do that the same thing. And then when you see have more energy, in that third bullet point there, it's probably best that you highlight it, circle it, whatever. Okay. Now, speaking of things that are incredibly important, is this concept here. Whenever we talk about electrons in these energy levels, there can only ever be a maximum number of electrons in each of these individual energy levels. And this concept and this idea of the maximum number of electrons in each of these levels is really important. So when I talk about the first principal energy level, and sometimes I'll just refer to them as PELs, so principal energy level, PEL. there can only be a maximum of 2 electrons in that first principal energy level. Okay, just a max of 2. In the second principal energy level, second PEL, there can be a maximum of 8 electrons. Okay, so now we're jumping from 2 all the way up to 8 in the second PEL, the second principal energy level. In the third principal energy level, the third PEL, there can be now a maximum of 18 electrons placed or to be placed in that third principal energy level. So we can keep expanding on the number of electrons that are placed in these principal energy levels. And now lastly, in the fourth PEL, and that's kind of where we're going to top off here, the fourth principal energy level, there can be a maximum of 32 electrons placed in just that fourth principal energy level alone. Okay, so we're going from 2 in the first all the way up to 32 in the fourth principal. Okay. Now, here's the Bohr model. Right here is what I was referring to a second ago. Okay. Again, the nucleus is in the dead center here where our protons and neutrons are. The first shell, sometimes I refer to them as shells, the first principal energy level is this one closest to the nucleus here, right? So again, this slide here should look relatively important or relatively similar to what you guys saw last chapter in chapter 4, right? We're talking about the Bohr model. So this first principal energy level here is the one closest to the nucleus, closest to the protons and neutrons. The second ring here, the second shell, is the second principal energy level for this Bohr model. And then this one way out here, the one farthest away, the one farthest away from the nucleus is going to be the third principal energy level. Okay, so those are the particular principal energy levels in the nucleus, or in an atom, rather. Now, valence electrons. Okay, valence electrons are things that I mentioned to you guys very briefly last chapter. So when we were talking about the periodic table towards the end of last chapter, we were talking about the different groups, right? Those columns up and down, right? So think about alkali metals, think about alkali earth metals in group 2, groups 3 through 12, right? With our transition metals, that big chunk in the middle of the periodic table of all those like metals like gold, silver, zinc, iron, all that stuff, right? I mentioned the word valence electrons in there, so you know, a few guys might recognize and remember that. But valence electrons, what are they? Why are they important to us? And honestly, why are they really, really important to us? Because they are really, really important to us. Well, valence electrons, guys, they are electrons that are present in the outermost energy level. Okay. So, if we were to look back at this Bohr model here, guys, so again, guys, this right here, this is our first principal energy level, right? I'm drawing a really, really horrible circle. Okay, I'm a chemistry teacher, not an art teacher. Okay, but that area, right, that circle, that principal energy level is our first principal energy level. And it's the one closest to the nucleus. I can only have a maximum of 2 electrons on this principal energy level, right? So those dots I just drew on there are just 2 electrons. That's it. I can't put any more on that particular energy level, right? Now the second one here, which is this guy right here, draw an arrow this time, not a circle. Okay, this is the second principal energy level, and I can only draw a maximum of 8, or place a maximum of 8 electrons in here. So that's 1, 2, 3, 4, 5, 6, 7, and 8. Okay, it's 8 electrons on this second principal energy level. Okay, but this particular Bohr model has a third principal energy level. Okay, it's our outermost in this case, right? There's only 3 principal energy levels in this Bohr model here. So this means any electrons I place on this third principal energy level are going to be my valence electrons, right? So if I draw 1, 2, and let's say 3, okay, these 3 valence electrons, okay, and I use a different color here to circle these, okay, so I'm going to circle this one, and this one, okay? These 3 valence electrons I just circled in our third principal energy level, which our third is also our outermost energy level. These 3 electrons on this third outermost principal energy level are our valence electrons, right? So there's 3 in this particular model here, okay? And that's just kind of an example of what you could potentially see with particular Bohr models, right, in terms of where your valence electrons are coming from, Now, back to valence electrons over here. Again, they are electrons in the outermost energy level, right? And it was the 3 that we just drew on the previous slide there. Valence electrons, it's never going to be more than 8, guys. That's one thing you have to really truly understand here. And the fact that in each of these principal energy levels, whenever we're talking about valence electrons, there is never going to be more than 8 electrons, 8 valence electrons. Okay, so whether it's the first principal energy level is your outermost, your second, your third, fourth, whatever, whichever one is your outermost energy level, the one furthest from the nucleus, is never going to have more than 8 valence electrons. 8 valence electrons. Okay, there are the maximums, right? So 2, 8, 18, 32, but when they're valence electrons particularly, never gonna be more than 8. Okay, so this idea of 8, guys, is your new favorite number. Okay, 8 means stable. If an atom of an element has 8 valence electrons, it is incredibly stable, and that's what we want. Okay, we want stability in chemistry. Chemistry is all about making things as stable and low energy as possible. And this kind of rule of 8 here comes from the octet rule. And OCT from octet means oct, or oct in OCT means 8, right? So think about an octagon, right? An octagon has 8 sides. Oct, octagon, oct, octet, 8. Okay, so the rule of 8 here is where this valence electron stuff comes from. Now, electrons in the ground state. This is kind of where we're going to leave off for today. This idea of the ground state. So this is kind of what I touched on a little bit last chapter when I said your number of protons equals your number of electrons, and that's for an atom when it's neutral, right? Well, neutral is the same thing or normal as ground state, and this is where a ground state electron comes from. Okay, so ground state, what does that mean? Okay, it's essentially the normal and stable electron configuration for an element, and it's listed in the bottom of the box for each element on the periodic table. So we're going to kind of base our Bohr models off of this electron configuration, and that's going to kind of be what we focus on in class when I see you guys tomorrow. So that's kind of where we're going to end off things today. Thank you for paying attention, and we will kind of go from here when it comes to this electron configuration stuff in class tomorrow. Thank you.